Okay, let's just mark A. There's 1A, number 1 and 2. Just pause if it's a bit too quick. And then yeah, we're busy with B, 1 and 2. Okay, so at this one, because it's division, I'm going to subtract my exponent. So it would be x to the power of 6. Okay, then number 3, a to the power of 17 divided by a to the power of 21. Because we're dividing, I'm going to subtract my exponents. Please remember that it's always the top exponent minus the bottom exponent. Okay, so my answer there will be a to the power of, good, minus 4. Right, number 4. X to the power of 6 in brackets to the power of 3. Now, when we have a power to the power, what do we do? With exponents, we're going to multiply. So that's the same as 6 times 3, which means that it would be x to the power of 18. Good. Number 5. xy to the power of 5. Now remember that 5 applies to everything inside the bracket. So it's actually x to the power of 5 times y to the power of 5. All right. Yeah. Yes. Yeah. So I didn't actually have to write that dot, but it's the same thing. Okay. Then number 6. Minus 4 x to the power 3 y to the power of 9 times minus 5 xy squared. Okay, so let's first look at the signs, then the coefficients, and then the unknowns. So a negative times a negative is going to give me a positive. I do not have to write that positive. Then 4 times 5 is going to give me 20. Now you could have said negative 4 times negative 5, and that's going to give you positive 20. Right? I'm just doing it bit by bit. Then x to the power 3 times x. Yes, there's nothing written there, but it's actually x to the power of 1. So if I were to add them, it's going to be? Yes, x to the power of 4, and then y to the power of 9 plus the 2, so 9 to the power of 11. Okay, any questions up until there? Yeah. All right, we first look at the sign and the coefficient. So technically minus 4, look at the board. Minus 4 times minus 5, and that gave me the positive 20. Then x to the power of 3 times x to the power of 1. Base is the same and we multiply, so which means I'm going to add my exponents. So the 3 plus the 1 gave me x to the power of 4. Then look at the y's. Y to the power of 9 times y to the power of 2. Again, base is the same, it's y, and we're multiplying, so I'm going to add those two exponents. So the 9 plus the 2 gave me that y to the power of 11. All right. Anyone else? Can I skip? Now we've got to do number 10. Just hands up, who's still copying? Phones down. Okay, right. Yes, you also had to do number 10. Negative 10 xy to the power 3 over negative 8 x to the power 3 y. Now what I'm going to do now is I'm going to cancel out. Can you see that the two negatives are going to cancel each other out? Sorry, okay. Right, now, yeah, but before we get there, let's look at the coefficients. 10 over 8. Now, if you're really struggling, use your calculator and say 10 over 8 and then equal. Okay? And then it's going to give you the simplified version. So what will go into both 10 and 8? What's the biggest number? 2. Okay, 2 will go into 8 how many times? Okay, so I'm going to have a 4 left. Oh, not that color, sorry. I'm going to have a 4 left there. Okay, 2 will go into 10 how many times? 5. Right. So, who said something about the x's? Okay, what can we do? Yeah? Can I cancel out that whole one? Okay, remember, we look at the exponents. We can only take the lowest exponent. Okay, so at the top, I've got x to the power of 1, and at the bottom, x to the power of 3. So I can only take 1. Yes, okay, so I take an x at the top, which means that at the bottom, I can only take one of those 3. So how many would be left? 2. All right, now let's look at the y's. Same thing. The lowest exponent is the 1, so I can take y. But over here, I can't take all 3. I can only take 1, which will mean 2 will be left. Okay, so now it looks horrible. So let's just rewrite what's left. At the top, I've got 5 y to the power of 2. At the bottom, I have 4 x to the power of 2. Is there anything else that I could maybe cancel out? No. Okay, so then you know that that is your final answer. Sometimes you might have missed anything else that could have cancelled out. So when you then rewrite what's left, you can then see if there maybe is something else that you could cancel out. Okay, and then just have an added step. Okay, any questions? Okay, so far we have done law 1 and law 2. Now I am on page 60 in your textbook. So let's quickly have a look at those. Can I skip over here? What? Yep. Yes, you may. Okay, can I skip? Is anyone else still copying? Do you say no, ma'am? Okay, but then you mustn't chat, you must copy. Tell me when you're finished. You're done. Good. Okay, so I am on grade 9. Alright, I'm on page 60. So the next law or rule that we want to look at is raising a fraction to a power. Okay, so let's write that. Raising a fraction to a power. So what will that look like? If I have a over b in brackets to the power of n. Can you see I've got a fraction and that whole fraction to the power of n? Yes. Good. Because that n applies to everything inside the bracket, it means that this is the same as a to the power of n over b to the power of n. Now, be careful. I can also give it the other way around. I can give you a to the power of n over b to the power of n, and then you should know that it's the same as putting the fraction in brackets and then say to the power of n. Okay, so you must be able to do it both ways. Okay, so let's look at an example. A over b to the power of 5. That will be a to the power of 5 over b to the power of 5. Okay, pretty simple. Let's look at another one. Number 2. Minus 3 over x to the power of 3, and that to the power of 2. Now, that to the power of 2 applies to everything inside the bracket, so it's the same as And listen carefully. That too applies to both the 3 and the minus. So can I write it like this? No, because then it only applies to the 3. So you have to keep brackets around that. Does everyone understand that part? Okay, at the bottom, I have x to the power of 3. I'm going to rewrite it like that. And then to the power of 2. Now, minus 3 to the power of 2 is the same as minus 3 times minus 3. And that's going to give me a positive 9. Then at the bottom, I've got x to the power 3 to the power of 2. When we have a power to the power, we have to multiply them. So that will be x to the power of 3 times 2, which will give me 6. Do you guys all understand that one? Okay, let's do another one. Quickly copy.
If there's a bracket or negative in the bracket, then automatically that should not positive.
Yeah, because a negative times a negative is going to give me a positive. Shh, shh, shh. Can I skip? Hands up, we're still copying?
Maybe at the time like this, not like when you're recording, maybe you should pause the video.
That's the thing, I can't. I can't pause it. If I there isn't a pause. So if I stop, it means I'm going to send you like 5 videos of one class, which you don't want. Yeah. Okay, can I skip? So when we mark homework, I can write it beforehand, but when I explain, there's no other way. Okay, right. Another example. Example number 3. 3x squared y over z to the power of 3, and that, all of it inside a bracket, to the power of 3. Okay, now that to the power of 3 applies to everything inside the bracket. So it's the same as 3 to the power of 3, x to the power of 2 times 3, because it's a power to the power. Yeah.
What is that denominator, ma'am?
Z. If I make a normal Z, it looks like a 2. So that's why I draw the stripe in the middle. Okay, so y to the power of 3, and then at the bottom, yeah. A what? A light. It's a projector. If it bothers you, you must move, because I can't switch it off, because then the projector goes off. And that's going to stay Z to the power of 3. Okay? So, no, I'm lying. 3 times 3. Sorry. Right, so let's simplify. 3 to the power of 3 is going to be 27. And then x to the power of 6. Y to the power of 3. And at the bottom, Z to the power of 9. It's a Z, y'all. If you see something looking like a 2 with a stripe in between, then it's a Z. Want ek skryf te lelik.
No, it's fine. No, it's just we don't know.
Okay, now, I want to quickly talk about negative exponents. Okay, can I skip the page? Did everyone copy this one? Okay, so who's not done?
Huh? Is it cancelled?
What's cancelled? Okay, right. Have a look. Forget about rugby. Have a look. Now, if I were to give you this, x to the power of 3 over x to the power of 5. Okay, now you guys know that when base is the same and we divide, what do? We minus. Okay, so I'm going to show you a few options. So usually you would say x to the power of 3 minus 5, and that's going to give you x to the power of minus 2. Now, okay, let's do that same thing, the long method. So x to the power 3 over x to the power 5 is actually the same as x times x times x, and at the bottom 1, 2, 3, 4, 5 of those, right?
I don't think anyone will ever use it.
No, you won't after today, definitely. Then we knew we could cancel out. So that x with this one, that x with this one, and that x with this one. So what's left here? At the top, Ollie, I have, at the top there were no x's left. But I can't just have nothing at the top, yeah? We're going to have a 1. And at the bottom, I have x times x, which is actually x to the power of 2.
Ma'am, it's fine, ma'am. I won't ever use this.
Okay, but
And do you have to write this
no,
down?
I'm still showing you something. Look at what was written over here and what's written over there. It's the same thing. Look at my answers. X to the power of negative 2, and over here, x to the 1 over x to the power of positive 2. But that is the same thing. Okay, now let me explain. I'm going to come back to this slide again. I know some of you might not have copied yet. So let me quickly show you. Negative exponents. Did you want to ask something? No. The short version you're going to do. I'm getting there.
Ma'am, you're still explaining the long version to us, right?
I'm now doing the short one.
Yeah, thank you.
I'm leading you towards the realization. Okay, so basically, if I have x to the power of minus a number, that's why I'm using n. It's the same as 1 over x to the power of positive n. So how I always remember it, right?
The negative is 1.
In a nutshell, this is actually over 1. No. So if you want to change, let me just rewrite it some. X to the power of negative n over 1. If you want to change a negative exponent to a positive, all you do is put it on the other side of the fraction. So if it was at the top, you move it to the bottom of the fraction, and then can you see the exponent is positive? No. And if it was at the bottom and it's negative, you move it to the top, and it becomes positive. Okay.
Ma'am, you just write 1 over x to the power of minus n. You just take away the minus.
Yes. Yeah. Okay. So what I wrote there is the official rule. So let's show you another one. So x to the power of minus 1 is the same as 1 over x to the power of positive 1. No.
Yes, ma'am.
This rule only applies to negative numbers.
Yeah, only to negative. Yeah.
That is
Okay. Must I quickly skip back to the previous slide again?
Ma'am, did you miss?
That one. Yeah, quickly copy that one. No, not everyone was done. We're still busy with the slide. Hands up who's copying? No one? Okay, copy that one. Okay, now what happens? Let's just make that number 1, this number 2, so number 3. So whatever I have this, a x to the power of minus n over b. Now I'm asking you to leave your answer in positive exponential form, meaning all your exponents must be positive. What's the exponent of the a? And is it positive or negative?
Positive.
Positive. So does that have to move?
No.
So the a is going to stay at the top, right? Okay. Let's look at the x. What's the exponent of the x? Minus n. I want it to be positive. So does it have to move?
Yes.
Yes. And what do I do to make it positive?
Move it down.
Move it to the other side. So that's going to move down. So at the bottom, I'm going to have x to the power of positive n. You don't have to write a plus in front of the n, right?
But you write the 1 on top of the x.
I'm going to get to that just now. Look at the bottom, the b. Did it have a positive exponent?
Yes.
So does it stay there? Yes. So there we go. Now, he just asked, do I have to write 1 at the top? If you want, you can say times 1. But a times 1 is still going to be a. So it doesn't matter. You don't have to write times 1. The only reason we did it over here at the example 1 and 2 is I can't just have nothing at the top. So then we always have a 1. Okay. So does everyone get number 3?
Yes, ma'am.
Good.
So now what's positive just stays where it is.
Yes. Yeah. It doesn't have to move.
Now, so will there ever be a chance that the negative is at the bottom?
Yeah. 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 I'll give you one just now. Right. Can I skip? Yeah. Okay. This one, number 4. He said, what if the negative is at the bottom? So x to the power of negative n. Right. Let's look at the top. At the top, I've got a, and is the exponent positive or negative? So does it have to move? Okay, so a is going to stay there. Okay, at the bottom, x to the power of negative n. It's a negative exponent. So what do? Move it to the top. So it's going to become x to the power of positive n. Now, what's left at the bottom? 1. And that is like a whole number, right? So it's the same as just saying a x to the power of n. You don't have to write it over 1. Like any other whole number, 4 over 1 is the same as just 4. X over 1 is just x. Okay, so it wouldn't be wrong if you left it like that, over 1. Okay, but it's the same as saying just a x to the power of n. Any questions? Good.
Now are you going to give us a bigger activity?
Ooh, one more. What?
Asking.
Wait. Okay, last one. If I give you x over y, so it's a fraction, and then to the power of negative n. Now, we said that when we have a fraction and a power outside the bracket, it means that that exponent applies to everything inside. So it's the same as x to the power of negative n over y to the power of negative n. But now we don't want negative exponents.
But both of them are limit already negative map and 2 negative.
So what's going to happen? No. So basically, that one is going to move to the bottom, and this one is going to move to the top. So they're just switching places. No. So it's going to become y to the power of n over x to the power of n. Now that is the same as y over x to the power of positive n. So now I want you to look at what we started off with over here. Look, look, look. What did we start off with? Joshua, take that thing out of your ear. What did we start with? X over y. What did we end with? Y over x. So you do not have to do all these steps in between. When it's inside a bracket and it's a negative exponent, all you've got to do is make the exponent positive, and that means the 2 inside the bracket will switch around. Okay, yes. Yeah, that's what you wanted to say, no? You don't have to show these steps. I showed it now to explain to you how you actually got to that. You can go from here to that. Yeah? Yeah. Yes. Okay, now you guys are going to have some of exercise 2, but my thing is still updating. So I'm gonna send the homework on the classroom or the WhatsApp group. Okay. If it's finished now, I'll quickly try and check it.